Hello viewers, in this video I'll continue with index numbers and I will discuss different methods to find index numbers. Those methods include simple average of relatives method, weighted aggregative method, Laspeyre's index, then Parches index and Fischer's ideal method. Now first we will see what is simple average of relatives method. According to this method, we have to convert the price of each commodity into percentage of the base period. So we have to convert the price of each commodity, that is we have to find the relative index for each commodity, and then we have to calculate the average of all such relatives. So we have to calculate the relative index for each commodity and then we just have to find the simple average of all those relatives. Then such a method is called the simple average of relatives method. Here there is one advantage is that the index number calculated from relatives will remain the same regardless of the units of each commodity. So that is one advantage of this method. Now we will see an example as to how we can use this method to find the index number. So here is an example. So for this example we have to use simple average of relatives method to find the index number. So here we are given the commodities A, B, C and D, then the unit price in the base year 2000 and the unit price in the year 2008. We need to find I, the index number for 2008 using 2000 as the base year. So according to this simple average of relatives method, we have to find the index number first by calculating the relative index for each commodity. Now we know how to find the relative index. The relative index, it is calculated as for commodity A, it is price in the current year upon price in the base year into 100. So it is 3.8 upon 3.2 into 100. Then now that is approximately equal to 119. And then for commodity B, the relative index is price in the current year upon price in the base year into 100. So it is 2.1 upon 1.7 into 100. So this is approximately equal to 124. Then we have for the commodity C, the relative index is 149.5 upon 148.1 into 100, and this is equal to 101. Then for commodity D, the relative index is 45 upon 34 into 100. This is approximately equal to 132. Now using this simple average of relatives method, we can find the index by simply taking the average of all these relative index values. So it is equal to 119 plus 124 plus 101 plus 132 upon 4. So this is equal to 476 upon 4, or it is equal to 119. So this is how we can use simple average of relatives method to find the index number. Again, this method also has got its own limitation. This method is also flawed to an extent as it gives equal importance to each commodity's relative. So again there is problem in this method also. So we will move on to the next method. The next method is called the weighted aggregative method. Now coming to the next method, which is weighted aggregative method. Now this method has some advantages over the simple aggregative method or the simple average of relatives method. The first one is it provides a better and more accurate comparison when the data items have variation of weights. Then it also it has information which includes factors such as quantity sold or quantity consumed, and appropriate weights are assigned to different commodities to make them comparable. And because of the allotment of weights, it enables the commodities of greater importance to have more impact on the index number, which is very, very important. So those commodities having higher weights will have greater importance, and accordingly their index number will also show the importance of those commodities with higher weights. Now we will see how to go about with this method. So according to the weighted aggregative method, the index number in time period n, which is given by In, it is calculated as summation Pni into Qi upon summation P naught I into Qi into 100. So this is the formula which we have to use to find the index number using weighted aggregative method. Here In represents the weighted aggregative index, then the next one is Qi. It shows the quantity of usage for commodity I, or it is the weight for commodity I. And then we have the next one, which is P naught I. It represents the unit price for base period 0. And the next one, Pni, it represents unit price of commodity I for the current period n. So using this formula, we can find the index number for weighted aggregative method. Now we will see some exercise questions. The question number 6, it is given based on the data on the expenses of middle class families in a certain city. Calculate the cost of living index during the year 2003 as compared with 1990. So here we are asked to calculate the cost of living index. They have given the expenses in the year 2003 and in the year 1990. So the expenses for food in 2003 is 1,500 and in 1990 it is 1,400. For fuel it is 250 in 2003 and in 1990 it is 200. Then we have clothing in 2003 750, in 1990 it was 400. Then rent 300, 200, and then finally we have miscellaneous. In 2003 the price it is 425 and in 1990 the expenses it is rupees 250. Now we have to calculate the cost of living index. So we can use simple aggregative method to find the cost of living index. So using simple aggregate method, we have I 2003 is equal to summation Pn upon summation P naught into 100. I have discussed about simple aggregate method in my previous video on index numbers. So how to find this, the steps required, all these, the video can be referred. Now here using simple aggregate method, the index number for 2003 is given by the sum of the prices in 2003 upon sum of the prices in 1990 into 100. So the sum of the prices in 2003, if we add all these, we will get summation Pn. So here if we add all these, that is if we add 1500 plus 250 plus 750 plus 300 plus 425, we will get the sum of the prices in 2003, and that is equal to 3225. Then next we have summation P naught. Summation P naught is the price in the, that is the sum of the prices in the base year. So here the sum of the prices in 1990 is 1400 plus 200 plus 400 plus 200 plus 250. It is equal to 2450. So this is equal to 3225 upon 2450 into 100. So when we simplify, we get 131.6 or it is approximately equal to 132. So using simple aggregate method, we have found the cost of living index during the year 2003 as compared with 1990. The formula is summation Pn upon summation P0 into 100. Summation Pn is the sum of the prices in 2003 and summation P0 is sum of prices in 1990. So when we add all these, the sum of prices in 2003, we get 3225, and when we add all the prices in 1990, we get 2450. So using this formula, we get the index as 132. Now coming to questions on weighted aggregative index. Compute the weighted aggregative index number for the following data. So here we have the variable x, y and z, and then we have the price for the current year and the base year, and then we have the weights for each of these. So the price for current year for x is 5, for y is 3, z is 2. Price in the base year, x is 4, y is 2, z is 1. And then the weights for x is 60, y is 50 and z is 30 respectively. Now we have to find the weighted aggregative index. So the formula, first let us write the formula. So the weighted aggregative index, it is calculated as In is equal to summation Pni Qi upon summation P0i Qi into 100. So here In is the index for the current year, then Pni refers to the price in the current year, P0i refers to price in the base year, and Qi refers to the weights. Now we'll draw a table like this so that it will be easy for us to find the answers. So this is the current year. The current year means the price is Pn, and this is the base year. It is P0. This is Pni, this is P0i, and the weights is Qi. So first let us find Pni into Qi, and then let us find P0i into Qi. So Pni into Qi is 5 into 60. So 5 into 60, it is 300. Then we have 3 into 50. 3 into 50, it is 150. Then we have 2 into 30. 2 into 30 is 60. Then we have P0i into Qi. So it is 4 into 60. So 4 into 60, it is 240. Then we have 2 into 50. That is P0i into Qi for y will be 2 into 50. So here 2 into 50, it is equal to 100. Then we have 1 into 30. So 1 into 30 is 30. Now if we add all these, we get summation Pni Qi. This is equal to 300 plus 150 plus 60. It is equal to 510. And if we add all these, we will get summation P0i Qi. Summation P0i Qi will be 240 plus 100 plus 30. So it is 370. So In, as I already mentioned, the formula is given by summation Pni Qi upon summation P0i Qi into 100. So it is equal to 510 upon 370 into 100, or it is equal to 137.8. This is approximately equal to 138. So this is how we have to find the weighted aggregate index. So first, this is given in the question. So for variable x, for each of the variable, we need to find Pni Qi and then P0i Qi. This Pni Qi, it is nothing but it is the price in the current year into the weight. So it is 5 into 60, 300. Then we have 3 into 50, that is 150. Then 2 into 30, it is 60. Then we have P naught I into QI, that is the price in the base year into the weights. So it is 4 into 60, 240. Then 2 into 50, 100. Then 1 into 30, 30. The formula for finding the index number using weighted aggregate method is given by In is equal to summation Pni Qi upon summation P naught I Qi into 100. So when we add all these, we get 510. So it is 510 upon, when we add all these, we get 370. So it is 510 upon 370 into 100, which is approximately equal to 138. Now we have the next method of finding the index number given by the French economist Laspeyre. It is called Laspeyre's index. What he has recommended is that the weights that are used, it should be based on the base period usage. So if the fixed quantity weights are considered from base period usage, then the weighted aggregate index is known by a new name, which is called Laspeyre's index. So according to Laspeyre, the index number in time period n, it is given by In LA is equal to summation Pni Q naught I upon summation P naught I Q naught I into 100. So this is how we have to find the index using the method devised by Laspeyre. According to him, he has recommended that if we use the quantity consumed during the base period as weights, then the index number will be better. So the index number is given by summation Pni Q naught I upon summation P naught I Q naught I into 100, where INLA, it represents weighted aggregative index using Laspeyre's method. Then we have Q naught I, it is the quantity of usage for commodity I in the base period. Then we have P naught I, it represents the unit price for base period 0. And then we have PNI, it represents the unit price of commodity I for the current period n. So this is how we have to find Laspeyre's index, by taking the quantity of usage for commodity I in base period. Now coming to the next index devised by the German statistician by the name Paasche. It is called Parches Index. It is named after him, and he has said that when the fixed quantity weights are considered from the current period usage, then the weighted aggregative index is known by another name. It is called Parches Index. So initially we saw Laspeyre's index. There the fixed quantity weights are considered from the base period usage, whereas here it is from current period usage. So index number in time period n, according to Parches method, it is given by INPA is equal to summation PNI QNI upon summation P naught I QNI. So this is the formula that we have to use to find the index number using Parches method, where INPA represents weighted aggregative index by Parches method. Then QNI is the quantity of usage for commodity I in current period n. And then we have P naught I, it represents unit price for the base period 0. And PNI represents the unit price of commodity I for the current period n. So this is how Parches index and Laspeyre's index differs. There we will be having, instead of Q1I, we will have Q naught I, whereas here we will have Q1I, Q1I. Now coming to the next method called Fischer's ideal method. According to this method, we can use the geometric mean of Laspeyre's and Parches index to find the index number. So the index number in time period n, it is given by INF it is equal to root of summation Pn Q naught upon summation P naught Q naught. This is Laspeyre's index into summation Pn Qn upon summation P naught Qn. This is Paasche's index into 100. So this is how we can use Fischer's ideal method to find the index number. Now we'll see the exercise question on Laspeyre's, Paasche's and Fischer's ideal method. So the second question, it says construct price index number from the following data using Laspeyre's method, Paasche's method, Fischer's ideal method. So we will do each of these methods one by one. So here we have the commodity PQRS, then we have the price for the year 2008 and for the year 2010. So we have to find the index for 2010 using 2008 as the base year. And then we have the quantity for year 2008 and for year 2010. So we have to find the price index using each of these methods. So first let us use Laspeyre's method to find the price index. So here we have the commodity P, Q, R and S. Then in Laspeyre's method we have to use the base period quantity, that is Q naught I. This quantity we have to use for Laspeyre's method. So here we have P naught I, then Pni and Q naught I. Here we have P naught I, Q naught I and Pni, Q naught I. So P naught I is 2, 5, 4 and then 2. Now Pni is the price in the year 2010. So it is 4, 6, 5 and 4. Q naught I is 8, 12, 15 and 18. So first let us find P naught I, Q naught I, that is we have to multiply each of these. So 2 into 8, 16, then 5 into 12, 60, then 4 into 15, 60, then 2 into 18, 36. So this is P naught I, Q naught I. Now let us find Pni into Qni. So this is Pni and this is, Q naught I. So it is 4 into 8, 32 for commodity P. Then for commodity Q it is 6 into 12, 72. Then for commodity R it is 5 into 15, 75. Then for commodity S it is 4 into 18, 72. So the formula to construct the price index using Laspeyre's method, it is given by I 2010 LA, it is equal to summation Pni Q naught I upon summation, it is P naught I Q naught I into 100. Now we have to add all these. So when we add all these, that is 32 plus 72 plus 75 plus 72, it is 251. So this is 251. So when we add all these, we get 251, and when we add all these, we get 172 upon 172 into 100. Summation P naught I, Q naught I is the sum of all these, that is 16 plus 60 plus 60 plus 36. So it is 172. Now 251 upon 172 into 100, it is equal to 145.9, or it is approximately equal to 140. 46. So this is the Laspeyre's index. So according to Laspeyre's method, we have to use the base period quantity as the weights. So this is the base period quantity. So using this as the weights, we have to find the weighted aggregate index. So it is given by summation P n I Q naught I upon summation P naught I Q naught I into 100. So summation P n I Q naught I, it is 4 into 8, 32 plus 6 into 12, 72 plus 5 into 5, 75 plus 4 into 18, 72. So when we add all these, we get 251. Then upon summation P naught I Q naught I. So it is 2 into 8, 16 plus 5 into 12, 60 plus 4 into 15, 60 plus 2 into 18, 36. So when we add all these, we get 172. So 251 upon 172 into 100 is approximately equal to 146. Now we will move on to the next method. The next method is Parches method. According to Parches method, we have to use the current period quantity as the weights. So here we have P naught I, then P n I, 2, 5, 4 and 2. Then here we have 4, 6, 5 and 4. And we have to use the current period quantity as weight. So it is 5, 10, 12 and 20. Now let us find P naught I, Q n I and P n I, Q n I. So P naught I, Q n I is 2 into 5. 2 into 5, 10. Then for Q it is 5 into 10, 50. Then for R it is 4 into 12, 48. Then for S it is 2 into 20, 40. Now let us find P n I, Q n I. That is 4 into 5, then 6 into 10, then 5 into 12, then 4 into 20. So 4 into 5, 20, 6 into 10, 60, then 5 into 12, 60, then 4 into 20, 80. Here if we add all these, we get summation P naught I, Q n I. So it is equal to sum of all these. So it is 148. And then if we add all these, we get summation P n I, Q n I. Summation P n I, Q n I is 20 plus 60 plus 60 plus 80, or it is equal to 220. Now the Parches Index, it is calculated as I 2010 PA, it is equal to summation P n I, Q n I upon summation P naught I, Q n I into 100, or this is equal to 220 upon 148 into 100. Now this is equal to 148.6, or it is approximately equal to 149. So this is Parches Index for 2010. So here we have to use the current period quantity as the weights. So it is calculated as summation P n I, Q n I upon summation P naught I, Q n I into 100. So summation P n I, Q n I will be 4 into 5 plus 6 into 10 plus 5 into 12 plus 4 into 20. So it is 220. Then summation P naught I, Q n I, it will be 2 into 5 plus 5 into 10 plus 4 into 12 plus 2 into 20. So it is equal to 148. So 220 upon 148 into 100, it is approximately equal to 149. Now the next method is Fischer's ideal method. The third method is Fischer's ideal method. Here we calculate the index as geometric mean of those two indices, that is Laspeyre's and Parches indices, or it is equal to root of summation Pn Q naught upon summation P naught Q naught into summation Pn Qn upon summation P naught Qn into 100. So this is equal to, so using Laspeyre's method, summation Pn Q naught upon summation P naught Q naught is 251 upon 172. So this is root of 251 upon 172 into summation Pn Qn upon summation P naught Qn. So using Parches index, here it is 220 upon 148. So it is 220 upon 148. So this is equal to into 100. So this is equal to root of 1.46 into 1.49 into 100, or this is approximately equal to 147. So the Fischer's ideal method, we have to find the index using the geometric mean of Laspeyre's index and Parches index. So this we have already calculated. Laspeyre's index we calculate as 146 and Parches index was 149. So this is the formula that we have to use to find Fischer's index. So it is root of 1.46 into 1.49 into 100, or it is equal to 1.47, approximately equal to 1.47 into 100. So it is approximately equal to 147. I hope this video was useful for you. Thank you for watching.